Logarithms, introducing logarithms. A logarithm is the inverse function to exponentiation. Any exponential equation, a to the b power is equal to c, can be rewritten as log base a of c is equal to b. And so if we zoom in a little bit there, we can see that this a is written lower than the log, and the c is sometimes written in parentheses, but not always. The c is called the argument of the logarithm. All right, so this is read as log base a of c equals b. That's how we read this. Log base a of c is equal to b. Logarithms are especially helpful when there is a variable or an unknown value in an exponent. So we're going to see that's when these things become really helpful. So let's, I should have gone over here to example 1 and 2. So we can rewrite each of these as log base 3 of 9 is equal to 2, and log base 16 of 4 is equal to 1/2. So notice that the base of the exponent here is 3, and the base of the logarithm is 3. The base of the exponent is 16. The base of the logarithm is 16. To solve problems like the ones in examples 3 and 4, the first step is to rewrite the equation in the form of a logarithm. Then we can use a calculator to finish solving. All right, so let's look over here at examples 3 and 4. So writing this as a logarithm, log base 2 of 256 is equal to x. So I can pull up a calculator here, and on the Desmos graphing calculator, that's the easiest place to work with these. If you click on the keyboard there, the functions will give you the logarithm right here. And we want the one that is the base a here. Okay. And so the problem we were looking at was log base 2 of 256. And then we can, we can just hit enter and notice that it equals 8 right there. So if we go back to there we go. So this is x is equal to 8. And I'm going to then do the next one here. Log base 5 of 0.04 is equal to x. So if we go back to that calculator now, I'm going to leave this just like that and just change that 2 to a 5 and the 256 to 0.04. And then x is -2. So we have x equals -2. Okay. Other kinds of problems are common when working with logarithms. In examples 5 and 6, we can use a calculator in the first step to find x. So on 5 and 6 down here, we can just put in the calculator log base 2 of 8. So log base, and I just noticed that I had to hit the down arrow to get into that base. Log base 2 of 8 is 3. So here we have log base 2 of 8, x is equal to 3. So it says over here then that we can use we can verify our solution to these kinds of problems by rewriting the problem in exponential form. So I'll show you what I mean by that. So if we convert this logarithm back into an exponent and replace the x with 3, what we have is base 2 to the third power equals 8. And that's true. 2 times 2 times 2 equals 8. Solving the next one, log base 5 of 25. So go in here to the logarithm and do log base 5 of 25, and it's 2. So we have x equals 2. And if we rewrite this, we have base 5 to the second power equals 25. And that's true. 5 squared does equal 25. All right, so in problems, examples 7 and 8, the problem is given in logarithmic form. And to solve, we must rewrite them in exponential form. So we can rewrite these as x squared equals 36. And then we can square root each side, and we get x equals, well, the square root of 36 is positive or negative 6. On the other one, 4 to the third power is equal to x. Well, 4 to the third power, 4 times 4 is 16 times 4. 16 times 4, is that 54? Let's see, 4 to the third power, 64. Yeah, that's right. All right. Sorry about that. So that's going to be 64 is equal to x. All right. If a logarithm is written, but there is no number where the base is written, that means the base is 10. Look in example 9 here. So notice that there's no base written there. Well, that means that it's log base 10 of 4. So we could go to our handy dandy Desmos graphing calculator here and do base 10, whoops, base 10 of 4. And we get 0.6025. Now, the other thing we could do is we could go into the functions here and notice that this logarithm doesn't have a base. So if we just do log of 4, notice it's the same thing because Desmos also knows that if there's no base written in, then it is going to be base 10. So this is going to be approximately 0.602. So I can answer approximately 0.602. And I always make sure to put those wavy equal signs to make sure folks know it's an estimate. So that is the introduction to logarithms.